All right, these are the lecture notes for April 1st, 2020. Unbelievably, it's already April, my birthday month, yay. So today we're going to talk about how energy can change form, but it is never lost. Energy can be converted from one form to another, and sometimes when we think that energy is lost, it's not lost. It's converted to something that we're not aware of. Often energy must change forms in order for it to be useful. So sunlight is one of those things where it radiates down, but for plants to have use of it, the plants have to take that sunlight and convert it to something. So they have to change it to glucose, C6H12O6. So many energy transformations occur between potential and kinetic energy. An example of this might be a ski jumper who's sitting at the top of a slope. And that ski jumper has the potential energy, potential gravitational energy. It's sitting at the top of the slope. Once that ski jumper starts moving down the slope, that potential energy is converted to kinetic energy. Now, the ski jumper has the ability to regain that potential energy by getting on a chairlift and going back up the slopes to do the run again. When gasoline is burned in a car engine, it's chemical energy that's produced as it converts the car into motion. The energy that's released, the kinetic energy that's released, is chemical energy, and it's the energy of particle motion that occurs within a gas combustion engine. Energy is also conserved. The law of the conservation of energy states that energy is neither created nor destroyed. So when it appears that energy has been lost, it's simply changed form, or it's been transferred to another object. And I'm going to give you an example of that when you kick a ball. You bring your leg back. While you're holding your leg back, you have potential energy. When you release your leg, the leg swinging forward is kinetic energy. When your foot connects to the soccer ball, you've transferred that energy to the ball. And now the ball has kinetic motion. All right, so sometimes the energy will transform. Sometimes it will change or be transferred to another object. So again, if we go back to an example of a soccer ball, when we kick a soccer ball, we also have energy that's converted into sound and into heat. All right, so I want you to think about your foot connecting to the soccer ball. Is it silent? It's not. You can hear it, right? Boom, and the ball goes forward. So that kinetic motion of your leg also converts to sound energy. And then the heat energy obviously is the movement of the ball forward. The other thing that we do want to make sure we talk about is that energy conversions can produce unwanted forms of energy also. So when an energy form changes, the total amount of energy does not change. All right, so again, energy is always conserved. So with whatever force you were drawing back to kick that ball, that force is the same when it's transferred to the ball. The same amount of energy gets transferred to the ball. It might be changed into heat energy and sound energy, but it's the same amount of energy. So sometimes when we convert it and we get these unwanted forms, we have to think about energy efficiency. So we talk about that a lot in terms of home development and building homes. We want energy conversion to be efficient. We don't want wasted or unused energy that's just let loose into the atmosphere, right? We want energy efficient appliances and stuff. And that goes back to, an efficient use of energy, all right? So we want to make sure that we actually convert our energy into a desired form. Now, the other thing I wanted to talk about today is that heat is energy. So everything is made up of atoms and molecules. These tiny particles move around a lot. We've talked about that repeatedly this year. And the more energy they contain, the more they move. And again, heat applied to an atom causes more movement. All right? So if energy makes things move, if things get warmer, They move more. So I want you to think about this as an example, the old-fashioned thermometers, not the electronic ones that we stick on foreheads and stuff nowadays, but the old-fashioned ones that have the mercury in the center. I'm sure you've seen those in science labs and use them for science experiments. If you take just an ordinary thermometer and you place it in your hand, the substance that's in the tube in that old-fashioned thermometer is called mercury. And mercury expands when heated. That's the other thing that heat does, is it causes things to expand. So if you're holding this thermometer in your hand, what are you going to see happen? You're going to see that mercury expanding and moving up the tube. And it's measuring. We're able to measure it as it goes up the tube, usually in Fahrenheit. The more you hold it and the warmer your hand gets, the farther up the tube that mercury goes. So it's causing, that heat from your hand is causing motion. Okay, it's causing the expansion of that mercury. So I want you to think about this in terms of, and this will probably be our discussion question, is if you place a pan of water on the stove and you turn the stove on, what happens in terms of energy? What is occurring in terms of energy? Another key idea that we want to talk about is how heat moves. This is, again, another misconception that people have about how heat moves. We don't actually cool things down. Cold does not transfer to hot. Heat transfers to cold. All right? So we kind of have to re-educate ourselves on this. So when you create when you put a bunch of ice in a cooler and you stick your water and your soda in there, you do it, we say, oh, let's cool it down, let's get it cold. But in actual fact, all you're doing is the heat that exists within the water bottle or the soda is actually transferring to the ice, and it's melting the ice. It's going to get colder. Your fluid, your drinks are going to get colder because they're losing heat. They're not gaining cold, they're losing heat. So that's an important thing to know, is that heat energy always transfers from hot to cold. So again, another example of this might be a slice of pizza. It's too hot to eat. So what do? We sit it on the counter and let it what? Cool. Exactly. So the heat from the pizza slice is transferring to the atmosphere around it. It's losing heat. It's not, the room is not making the pizza cooler. The pizza is actually making the air around it warmer. If that pizza's cold, the next morning we're gonna have pizza for breakfast, we stick it in the microwave. We are transferring the heat of radiation to the pizza. Hot to cold again, never the other way. The other thing that we want to talk about very briefly today is the concept of heat versus temperature. These are two very different things. Heat is a form of energy that's measured in joules. It can be converted into other forms of energy. Temperature is the measure of the hotness of an object. So temperature is the measurement of heat. Heat and temperature are two very, very different things. We've talked about how heat can make things expand. Because heat is energy, and we know that the greater the heat is, the more we make atoms and molecules move, we can also state that heat makes things expand. Water is a very obvious one to talk about when we talk about heat making things expand. As an ice cube melts, what happens? Well, those bonds get looser and they start moving, don't they? And we have a liquid. We heat it up even further, and those molecules continue to expand farther and farther apart, and we have a gas. Most things have a melting point, so not everything evaporates the way water does in terms of those molecules getting agitated and moving, but we have metals that will melt at certain temperatures, and everything has a unique melting point, which is something we're going to talk about as well in terms of science. But if you think about old-fashioned blacksmiths forging swords and stuff, what were they doing? Well, they were creating these huge furnaces that they were putting hard steel in, and using bellows they were making that fire so hot that it would not often melt, although sometimes melt, but usually would loosen up the bonds in the metal so it becomes more pliable. So it allows it to expand, and then they can use a hammer to pound it into shape. The more it expands, the more pliable it is and the easier it is to work with. So those are our main concepts for today. We will tomorrow be talking about technology and energy. Look for your worksheets, and Thursday we will have office hours again at 10 a.m. to talk about what we're learning. I have been returning your work. I'm going to start transferring the grades into the Schoolmaster Gradebook, so you should be seeing by the end of tomorrow some grades if you want to go on to Family Link and check out how you're doing. If there's a due date on something, guys, you can't take 2 weeks to complete it and not lose points. You have to make sure you're turning your work in on time. Set aside time every single day. I'm trying to make sure that you're not getting any more work in science than you were getting when we were actually sitting in the classroom. All right? Okay, talk to you tomorrow. Bye.